My name is Doug Stevenson. I'm a developer advocate at Google, and I work with the Firebase team. Now, I'm not going to talk to you about Firebase. I figure most of you probably already know what Firebase is, and many of you, I'm sure, have played with it and gotten some good things out of it. But what I want to talk about is the Google Play Services Task API. So this Task API is the way that Firebase and Play Services will be exposing the way that it does asynchronous work going forward. So it was actually invented for Firebase. So Firebase is built for Android, is built on top of Play Services. Play Services then provides some services to Firebase, and this Task API is one of them. So the reason why the Task API exists is to support Play Services and Firebase. And I'll show you some Firebase examples. And again, the purpose of my showing the examples is not to sell you on Firebase. If they look appealing to you, that's to Firebase selling itself. That's not my fault. And if you have any questions, you can always talk to us at our booth. The Task API is meant to be ultra lightweight. So the jar file that encapsulates all of this functionality is 24 kilobytes. So jar files don't get a whole lot smaller. The Task API is supposed to be straightforward, so you should be able to just use it and it should just make sense. You shouldn't have to study it too much. There are a couple things I do want to unpack about it, so it can be well understood. And it's Android aware, meaning, as most of you know, as Android developers, Android has a very peculiar way of doing things like managing activity lifecycle changes when you have orientation changes. And if you've done any amount of work, you probably know that that can cause some problems, particularly with activity leaks and things like that. So the Task API is actually Android aware, and it has ways to help you deal with those situations when they arise. So there's a couple things that the Task API is not supposed to do, so don't misinterpret its existence. It is not here to replace other asynchronous APIs. So many of you are probably using something like RxJava or Agera or some other framework. That's fine. The Task API doesn't want to tell them they're wrong. The Task API actually wants to work with them. And I'll show examples of that about halfway through here. The Task API is also not opinionated about application architecture. So if you want to do clean architecture, that's fine. If you want to just put all your stuff in activities, that's fine. Task API doesn't care. It's not opinionated. It just wants to provide a service, and that service is to give you the ability to monitor background processes. So are there any JavaScript developers here? And it's kind of a weird question to ask in a room. Okay, one person. All right. So I was going to say, for those of you who are familiar with JavaScript and promises, or what promises do, so a promise, the Task API is built on top of what promises offer. So a promise basically gives you a resolve or reject API. So if you have a task in flight or a promise in flight representing some amount of work, that work terminates itself using either a resolution, so you get a resolve API, or reject API. So either success or failure. You get exactly one of those choices, and you get only one of those failures, or one of those situations. So when a task completes, either successfully or with error, that's it. The task is done. That result is forever baked in stone for that instance of that task forever. It's not like an RxJava observable where it can continue to produce results over time. It just doesn't do that. It's a one-shot kind of thing. So be aware of that. And you can register listeners on a task. And those listeners can either wait for resolution. So you can register a success listener, and that will get called when the task finally completes. Or there's an error listener that happens when it generates an exception. Now, if you have a task that's already completed and then you register a new listener on it, that listener will get called immediately. So you can use that to get the results of a task that already completed. So a task is basically a promise. It represents some amount of work, and it represents the results of that work, either some result type or some failure type. So that's a lot of words. Let's just look at some code. So what I've got right here is an example of how you might use Firebase Remote Config. So Remote Config is a feature of Firebase that lets you do remote configuration by manipulating key value pairs on the server, and then those key value pairs get distributed down to clients. So a lot of people use this for like string tables or A/B testing or whatever. You can manipulate the behavior of your app remotely by using this API. So what you do is, in this example, we're using the remote config singleton, and we're going to call the fetch method on that. And that fetch method basically says, remote config, go off and give me those results and tell me when you've got them. Now, this is potentially a network request, and we all know that network requests aren't fast always, so it can take any amount of time. So what it's going to do is it's going to return a task. And that task has to be parameterized, and in this case, it's void. Void just means the task doesn't generate any data. It's just a task. And then you register an onSuccess listener, and that success listener, again, needs to be parameterized by the same type as the task. And inside the onSuccess method, you're going to get a void, which is nothing, of course, so this is not the best example. But then after the onSuccess callback completes, you know that remote config has values for you. So this is a basic, straightforward example of how you use remote config and how a task basically works. Now there's, I went on too fast. So imagine that we're doing this inside activity on create, right? You know, everyone does initialization things in activity on create. Can you think of anything that could go wrong here? Seasoned Android developers, your spider senses might be tingling. If you do something like this, you register a listener in your activity, there's a potential here for an activity leak. So what's leaking here is actually this like private activity outer instance reference. So every anonymous class that's embedded within another class implicitly holds a reference to that outside class. This is a feature of Java. This is what lets inner classes reference the methods and member variables of outer classes. And so if this was inside an activity, that means we have this callback, this anonymous class, strongly holding a reference to the activity that kicked it off. Now, if this task outlives the original activity, the task is essentially going to hold on to that activity instance and it will leak. If the user navigates away or reorients several times, you're going to end up with all of these leaked activity instances being strongly held by these callbacks that are waiting to fire. So we need a way to avoid that. This is like really bad. So what we can do with the task API is use an activity scoped listener. What you can do with an activity scoped listener is essentially say, when I have a callback to call, and this is example code that I've modified slightly to use an activity scope listener, what we do is we pass in the activity reference. So this, in this case, refers to the outer activity instance. When you pass that instance, that tells the task API, if this activity stops, if it goes through its onStop method, unregister all my listeners. Just do it, just wholesale unregister everything on that task, because we know that that task could cause a leak, and we don't want that leak to happen. So this is what makes the task API Android aware. It's smart about listening to the activity lifecycle and doing the best thing. So one thing about listeners is that they're called on the main thread by default. So when you use the listener only or the listener only or the activity version, so I showed you two versions, those listeners get called on the main thread every time. Now, if you need to do some blocking work in your listener, don't run that on the main thread. I shouldn't have to tell you, don't run blocking work on the main thread. It'll cause jank, will cause problems in ANRs and things like that. So if you have a listener that you want to run and do more blocking work, like a database lookup or whatever you have, you can use a version of the add onSuccess listener that takes an executor as its first argument. If you pass it an executor, that tells the task API, don't run the listener on the main thread, schedule it for work in that executor. Now, for Java developers who haven't encountered an executor is basically an abstraction that lets you submit work that goes off to run on some other thread or some pool of threads. So this would be something that you create on your own, probably a singleton. You pass that instance in, maybe it represents a pool of threads that are available for work. And the task API will schedule the listener to run on that. Now this means if you're running on another thread, of course, you can't do UI updates on that, so you'll have to continue to bounce back and forth between threads as necessary. So that gives us three versions of the task API. So there's one that's just the listener only, there's one that takes an activity and that's scoped to the activity, and there's one that takes an executor, which lets you specify that you want to do it in the background. And there's three different kinds of callbacks. There's the success listener, which says the task generated a result, we know what the final result is, it's typed to the result type from the task, and that's good. There's also the failure case, so you can register an on-failure listener, which gives you an exception or something that went wrong. So you can listen for that and react accordingly. And there's a third type of listener called an on-complete listener, and that's just a fancy way of saying, well, it'll trigger for both success and failure. So what you have to do is, if you register an on-complete listener, you have to check, was it successful, was it a failure, and then react to it like that. So there's no real advantage to using complete over success or failure. You could register both of the success and failure, or you can do complete and check yourself. It's a matter of style, whatever you want to do. Okay, so you might be wondering, how does the task API know about the activity lifecycle? You know, there is one way in Android that you can listen to the activity lifecycle, and that's through those activity lifecycle callbacks. but that's only available on, I think, Honeycomb and later. So the task API works all the way back to Gingerbread, as does all of Play services. So the question is, if we can't use activity lifecycle callbacks, how does the task API know if the activity is coming or going? And this is kind of an interesting thing. If you're kind of an Android nerd and you like to get down into the bowels of things, I think the solution they have here is pretty interesting. So what it does is it registers a headless fragment to respond to activity lifecycle events. So many of you probably use fragments to cordon off a part of the screen and have it be its own little reusable display unit. Headless fragments don't have a UI. They're attached to an activity, but they don't have a UI. And so what we're doing here is we're attaching this fragment. It doesn't have a UI, but it still listens to the activity lifecycle. So attached fragments to an activity respond to its on start, its on pause, on resume, on stop. And so this fragment is essentially listening in on the activity lifecycle as it happens. So this fragment then receives the on stop if the activity is going to stop, and then it tells the task, hey, you should get rid of all your listeners. We don't want any activity leaks. And so the decision it's making is essentially the activity you pass. It's going to say, well, is this a fragment activity? Did this come from the compatibility library? Remember, there's two different kinds of activities. There's basic activities like platform activities, and then there's fragment activities which come from the compatibility library to sort of backfill the functionality that's missing in older platforms. So the decision we're making here is, well, the decision the API is making, if I'm dealing with a fragment activity, I'm going to add the fragment using the compatibility library fragment manager. But if we're not using a fragment activity, if we're using like an actual platform activity instance, we have to check to make sure it's API level 11 or later. And again, this is Honeycomb. The fragment API was added in, Honeycomb. So we have to check. If we're on API 11 or later, we can use those APIs. If not, our only recourse is to crash. We have nothing else to do. We have no way of listening in on the activity lifecycle at all. So just bear in mind, if you are using the task API and you're targeting greater than, less than Honeycomb, you need to be using fragment activities, the compatibility library version. And that's general best practice anyway, right? So be aware of that. So that's basic processing, right? You're going to call APIs, Firebase APIs or Play Services APIs. You get a task, you have a listener, that's great. But what if the listener isn't enough? What if you want to do further processing? So you want to do maybe a series of things in response to a task completing. So one pattern that comes up is you have a task. And that task calls into will want to be resolved by a bunch of things afterwards. In the task API, we call those continuations. So you're continuing on from an original task. And then you have a listener at the end of that chain that receives a final result. So the prototype for this, what a continuation typically looks like, a continuation is parameterized by two types. The type T, or I call it T here, that's the input type. That's what we're expecting as the result of a task. And the R type is some sort of transform type. So what we're trying to do is take the input T type and turn it into an output R type. And that's how you sort of chain together these continuations. So in the then method, and that will look familiar to you if you're familiar with the JavaScript Promises API, in the then method, we're going to get the task that was hooked up prior to us, and then we can ask it, what is your result? I'm a little bit behind. So we can ask the task, what was the result that came out of your processing? That's your type T. And what we're going to do is then pass that on to some sort of transformation. Maybe it's right here, maybe it's a function, maybe it's whatever. But we need to turn that into a type R. And that's basically what a continuation does. Probably more lines than what I've shown here. So let's look at a real example. So if you're using Firebase Authentication to get users logged into your mobile app, you will undoubtedly call at some point a method to get the user signed in. So in this case, we're going to call the sign in anonymously, and this is for anonymous login. If you have a regular login, it's a different method. They do generally the same thing. It's going to return you a task, and that task is parameterized by an auth result. That auth result represents the results of whatever the login process was. Then let's say that the auth result isn't exactly what you want. Say there's some sort of Java Pojo, a bean that represents a fully logged in user. And that's what you want at the end of this. You don't want the auth result. You want something transformed out of that. So what we'll do is new up something, and this is my invention, a load, what are we calling it? Load user info object. This is basically a continuation that takes an auth result as input, that's the type T, generates a user bean as output. So this is our transformation. And what we do is we take the original task that it gave us, we call continue with, and then pass it the load user info continuation. And you also notice that I'm using an executor here, and the idea is my fictional load user info continuation is going to block. It's going to make maybe a network request or a database request. We don't know, but it's going to block, so we have to keep it on the off the main thread, so we're going to use an executor. So to wire it all up, we take the lookup task, or I'm sorry, that is a typo. It should be load task, not lookup task. Anyway, what we do is we take the task that comes out of continue with. So what continue with does is it says, you don't need the original task anymore. You need this modified task that returns the modified result. So we'll add a success listener to that. And that success listener will then trigger an on-success call, which returns the type of thing that you want. And on the next frame, I'll show actually what this could look like. So our fictional load user info implements continuation. We define our input and output types. And inside the then method, we'll get the result. So that auth result is the thing that came out of the task, the result of the task. And then we'll do some conversion on it, right, and turn it into a bean. And this is the thing that blocks, and that's why we need to be off the main thread. Okay. So what happens if there's an error in a continuation? Like, how does that happen? If you have a chain of things that you want to happen and one of them fails, which is undoubtedly going to happen at some point, how does that work? How do you notify the listener at the other end? Well, it turns out continuations have this built-in ability to propagate errors down the chain. So what it does is, the key is actually the get result from the task itself. So when you call task.getResult and you're expecting a result, but you actually have an exception there, this silently throws an exception, and that's fine. It's wrapped up in a special exception that continuations know how to deal with. The continuation says, I'm going to throw a special exception, and then the next guy down the chain is going to actually receive that as an error input. And so, at each stage is going to keep calling get result. It's going to keep throwing an exception until finally it gets translated into the original exception that goes all the way down to that listener. So if you're worried about what happens in this sort of pipeline of processing, you don't really have to worry about it. It's happened automatically, or it's dealt with automatically by the task API. Okay. So what if you want to do parallel processing? So we've seen serial processing where you do things in order. What happens if you have multiple tasks and you want to know when they're all done at the same time? Well, in this case, there's a task API called, it's a static method called whenAll. And you pass it the collection or the individual tasks that you're interested in knowing when they're all done. And you can pass as many as you want, or you can do just one, it doesn't matter. But what you get out of this is a new task. And that new task represents the completion of all of the ones that you pass in. Now you'll notice this one is also parameterized by void. That's just saying that this task is just an event. It just tells you that all those other tasks are done. It doesn't aggregate all the results of them. If you're interested in the results, you have to reach back into the original task and get the results out. So what happens is when all tasks are resolved successfully, it will fire the on-success listener for that task. If any of the tasks resolved in an error, so if any one of the many that you pass in has an error, the on-failure listener will call it. So one error kind of ruins the whole batch. And it will also be called after they all succeed, or after they all finish. So if you had 3 that took 30 seconds and an error that took 5 seconds, well, that error is still going to take 30 seconds to reach your listener because it's going to wait for all of them to finish. And you can also register a non-completion listener, and that just tells you when they all finish. And again, you have to check them all for errors if you're interested in partial results. Okay. So that's parallel processing. There's one more thing you can do with the task API, which is block on a task. Now, I'm going to recommend that if you feel like you need to do this, you probably don't. You probably should never be interested in blocking anything. However, there are times when this comes in handy. So the tasks class has a static method called await. You pass it the name of the instance of the task you want to wait for, and it will block. And I think there's also a version of this that takes a timeout. But anyway, you will block the thread. And one of 3 things will happen. One, it'll complete and you'll get the result back, or the thread will be interrupted and you'll have to catch an interrupted exception, or the task will fail with its own exception and you'll have to catch that as well. So this can be handy if you need a task inside of a loader. So if you've ever used loaders, the thread that's operating a load has to block in order for the load to complete properly. And so in that case, if you want to put a loader around a task, this is how you would make that loader wait until the task is done. But again, generally, oh, by the way, never call this on the main thread. Never block on the main thread. I can't stress that enough. Don't block the main thread. Okay, so Now you can customize tasks, and this is kind of an advanced thing. But we use this in Firebase storage to give a task other powers, other abilities. So right now, a basic task, a plain task, only gives you the ability to wait for success and catch errors. But what if you wanted to be cancelable? Well, a task isn't inherently cancelable. So what the Firebase storage team did was they made up a special cancelable task, and they added a cancel method on it. And they made it so that an in-flight upload or download can be canceled. And they went further. They said, well, we need a task to be controllable. And their sense of controllable is that it can be paused and resumed. So if you have an upload in progress and you need to pause it, maybe because you need the bandwidth back or the user asks for it to be paused, you need methods to do that. So again, task doesn't provide that, but you can modify the task to do that for you. Then on top of that, they have something called a storage task, which lets you monitor progress. So if a task is going to take some time to complete and you want to make a progress bar out of that, well, what they did is they made storage tasks which lets you register progress listeners. So those progress listeners will get fired every so often to let you know how the transfer is doing. And then finally, the final task, this is one that you would actually deal with if you're using the Firebase APIs, sort of subsumes all of that. So an upload task or a download task is cancelable, and it's controllable, and it lets you listen for progress. And so if you want to add these kind of features to tasks, you can, and you can do it through a subclassing kind of mechanism. Okay. Does anyone have any questions about tasks so far? It's pretty straightforward stuff. Yeah, go ahead.
Why is it called storage task?
So storage task is the superclass of both upload task and download task. So that gives you the ability to listen to progress. So it should be like progress task. They called it storage task. I don't know. This is like the actual call hierarchy. I would have named it differently if I was building it, but I don't get to build it. Yeah, you had a question?
Yeah. Could you go into a little bit more depth on the when all tasks method? So what does the listener get? Like all of the tasks as some sort of collection that you can iterate through?
Yeah. So it returns a void, and so what it's saying is this task is. Oh, yeah, sure. So the question was tasks.winAll, the static method. What does it give you back after you've given it all the tasks and all the tasks are completed? Well, it gives you back nothing more than a notification that it completed. So all you have in hand is this task that gives you a void, but that void is clearly not useful. So what you have to do is remember which tasks you gave it, then reach into those tasks and ask you, did you have a success? Did you have failure? And so you kind of have to pull back into the original tasks.
So
Yeah.
whatever success listener I pass into add-on success listener doesn't get any of those tasks. It just kind of gets they're done.
Right. The on-success listener to the aggregated win-all task is just notified that they are all done. It doesn't tell you what the items are. Now, I've seen there's other Promise APIs that do give you the list of the original things that you passed in so that you can turn around and act to them without having to like store it in state somewhere, And I would have liked to see that to be the case, but this is the way it ended up. So it's something to be aware of. Okay. Were there any other questions about tasks? Yeah.
Is there an idea of a queue that the tasks go on so you can set like priority or concurrency? Or are they just loading up different threads and running them as?
So the question is there so how does it actually do the concurrency? Is there some sort of multi-threading or a queue? The answer is you don't know. The task is a very abstract representation of work in flight. It's up to the task provider to determine how to do the threading. So in the case of Firebase storage, if you have all these uploads or downloads happening, the storage API is the thing that's determining how many threads and which threads and is there a queue, and you don't know that just from the task itself. The API provider would have to expose that information if they wish to. All you're concerned about with the task is whether or not something finished, and did it finish with success or error. So, yeah.
So how does task differ from the old result class that used to be kind of for Google Play Services? Or is it basically just kind of a different name for the same sort of concept?
Yeah, so the question is, how is a task different from the old result type? So I think, it's been a long time since I've used those Google Play Services stuff. I think that it was essentially the same thing, where it's just saying, here's a thing that happened at some point, and we've passed it back to you. It's more of a container, right? It's a container of other things. So you'll notice that there's a result in the task API, or no, actually there's a result in Agera. I got confused. But yeah, so a task is basically that something finished and its data type that's, the thing that it represents. Except in the case of WinAll, where it represents just that it completed, so. Yeah. So anyway, you can expect to see this. I think Firebase is the only consumer of the task API right now, But the idea is that it's provided as part of Play Services for anything down the road. So I wouldn't be surprised if there were evolutions to the existing APIs that took advantage of this. Yeah.
What is a task class or the interface or the abstraction, as you said, a part of Google Play Services? I mean, why not be its own library that somebody who wants to use? I mean, should we rely on actually depending on the entire Google Play Services library?
Yeah, so
part of our APK just because you want to use the task?
Yeah, so the question is the task API its own library, or could it be its own library? The answer is yes, it actually is its own library. It has its own, I guess I didn't put that into a slide. It has its own like Maven target that you can specify. Now that Maven target does depend on Play Services Basement, which is sort of like a collection of utilities, which is actually much larger. But the idea is if you want to use just tasks, you can call out that API by requirement or by compile dependency and then make use of it. You probably want to use ProGuard at that point though to strip out much of Basement. but the task API largely stands alone. So. Okay. All right, so we'll move on. So the burning question is, I think for a lot of people is, I have a task in hand, I want to do something with it, but I'm actually an RxJava user and I want this task to participate in like my RxJava streams. Or I'm a Nagara user and I want to turn a task into a repository that I can listen to. The good news is you can do both of these things. The task API was meant to integrate with these other libraries. It's not, again, it's not a replacement and it's not an alternative per se. It's just the way that Play Services exposes its background work. So the tool that the task API gives you to listen in and convert tasks to observables and back and forth is called a task completion source. And all this does really is it provides a way to manually resolve or reject a task. So what you do with task completion source, the source code is super simple. You just new one up and you declare some type T that it's supposed to generate. Then you can immediately turn around and call getTask on that source. And that will return you a task that's waiting to complete. It's as if anyone were to listen on this task right after you call getTask, they would block. They would wait, or not, they would not block, they would wait for that result. Then what you can do is turn around and on the source, call setResult, and that stimulates all of the onSuccess listeners to say, here's the thing, here's the T you were looking for, the T you were waiting for. Or you can reject it, so you just call setException with some exception that you choose, and then all of the error listeners will get called with that piece of data. So this is the glue, and it seems pretty simple, but gluing together these different parts is a little bit more complicated. So I'll show how to do that. So if you're using RxJava, probably what you want to do is you might want to use convert a task into an observable. So if you want an observable to hook into your app lifecycle, you might be interested in like wrapping a task. Or the other way around. Say you have an observable in hand and you want that to work well with other tasks. So you want to use winAll to wait for something to complete. Or you want to use continuations to continue processing. Although for an observable that would be kind of silly because you already have sort of a set of continuations you can use in its own language. But we'll look at both of them. Now there is a caveat with observables that you've converted into tasks in that they only can trigger the first value. So if you know an observable, it's something that the value can change over time. So it's constantly potentially feeding you new pieces of data. But since tasks are one-shot only, they only ever have one value or one error, you can't expect this observable, a wrapped observable, to behave any differently than a task. The task cannot be coerced into giving you multiple values. It will only give you that first value. So if your observable is already going to give you one value, that's fine, but if it creates multiple, you're going to have to defend against that. So here's some code that gets you from a task to an observable. And if you're looking at this, I know the moment I look at this slide, my internal parser is like throwing errors because there's a missing brace at the bottom, and then there's another missing brace with the parentheses. So just so you know, in the original source code, those lines were there. If you're upset by it, like I am, then don't worry, they're really there. So what you can do here, this is the static method that takes a task as input and generates an observable in response. And so it's all parameterized by this type T, this thing this data type that's flowing through the system. So you use RxJava's create mechanism, and what you do is you take the subscriber that the observable is going to generate for you, and you say, for the task that I've been given, I'm going to add a success listener to it. And that success listener, when it triggers, will tell the observable, you have a new item of data. So that's the subscriber on next. And then it's going to tell the subscriber, you've actually completed. This is as far as you're going to go. you should stop listening. You're not going to get anything else. Same thing with a failure. We're just going to trigger the error handler on the observable, and we're going to tell it it's completed. And that's all there is to it. It's pretty simple. Now, there's a lot of, I see this as a lot of noise. There's a lot of generics and a lot of extra lines of code and callbacks, and I don't like that the other lines are missing. So here's what it looks like in Kotlin. I don't know if you've seen Kotlin. I applaud greatly for the enhanced syntax that Kotlin gives you. So I'm just saying that the Task API and RxJava look really nice when they're used with Kotlin. Now, I'm not officially endorsing saying you should write your Android apps in Kotlin. That's not my job as a Googler to say that. But it comes up enough times that, if the syntax gets hairy, you might be helped by Lambda expressions. Okay, so now what if we want to go the other way? What if we have an observable in hand and we want to turn that into a task that we can combine with other tasks? Well, it's similar. We have a static method called fromObservable. It's going to take an observable and return a task parameterized by the same type T. And we're going to use that task completion source that I talked about before. Now, the subscriber, so we need to pass a subscriber to the observable so that you can listen to what is happening within the observable. So in that subscriber, when we get a new piece of data, or the onNext method is called, we're going to tell the source, the task completion source, you're done, you're resolved, and here's the piece of data that you've got. Same thing with error. We can tell the task, you're done, here's the error, go on. Now, we don't need to implement onCompleted here, it doesn't make sense. But the point is, we can tell the observable, use this subscriber that resolves my task, and then just return the task from the event source. So this basically wraps. Now, there's a little bit of a caveat with this particular example is that if this observable generates multiple items of data, it'll end up trying to call setResult twice, which is actually an error in the task. It's a programming error to try to resolve a task twice. So you'll need to defend against that. But this fits so nicely into the slide, so I didn't want to add that extra code. Okay. Any questions about converting RxJava and tasks? Yeah.
What's the point? I don't understand. If you're using RxJava, why not just use the observable?
Right, so what's the point? The point is, if you're using Firebase APIs, they're going to give you a task. They don't know anything about RxJava, right? This is its own. So what happens is, say you get, say you're doing file upload tasks. It's going to give you a task saying, here's your upload task. This is what you have to use to measure how your upload is going. Well, that's fine. You have to either deal with the task or convert it into something that you'd rather have listening for events. And that's why maybe you want to hook that into a different observable chain. Or say you have one observable and like many tasks, and you want to wait for all of those tasks to complete, right? You want to use winAll. Well, you can't have winAll, a bunch of tasks, and some observable. That observable has to be a task. Then you can use winAll to listen to all of them. So it's a matter of interop. You're adapting one to the other in cases where it's needed. Does that make sense?
It's a bigger question might be why Google not use RxJava.
Well, it's not a push. I mean, well, remember the goals and non-goals, right? The goal is to provide a unified interface that all of Play services can use. We can't adopt something else. It needs to be small. It needs to be straightforward. So anyway, it's just its own thing. Okay. So what if you're using Agera? So Agera is actually a Google-created library that's similar to RxJava, except it has a very different paradigm of how to think about observables. So again, with Agera, you can turn a task into a repository, and the repository is sort of like the main item of data that you're dealing with, or main utility that you're dealing with in Agera. You can go both ways. Now, it's a little bit more complicated because Agera has a very different way of thinking about the world. It's very different than RxJava. So it has what they call a push event pull data model, which is to say that observables only ever indicate that something happened. There's no data attached to it. Observable only tells you a thing happened, a thing happened. It won't tell you which thing, it's just a thing, right? And so there's no data attached to it. And what you do with that observable is you register an updatable on that, and that updatable gets triggered. And again, it's only triggered on the fact that something changed, not what changed or not what its new value is. There's also a concept of a supplier, and this is just something that generates data, and it has one method, get. It just provides data, and that's all it does. But this data could potentially change over time, so you could call get on it multiple times, and the value could change. And then there's the abstraction that I'm most interested in talking about is a repository, which is both an observable and a supplier. So a repository is a place to get data. You can call get on it. It supplies data. But it will also generate events as that data changes. So if you push new things into that repository, the contract is you'll generate events that come out of it. So you can treat it like an observable and listen to its events. But you can also turn around and pull the data out of it when the event is triggered. So a little bit more about repositories. So we break this down even further. So there's two different kinds of repositories. There's one is static, where it has some value or it has some series of values, and that never changes. It is its own thing. In fact, a static repository never actually generates an event because nothing ever changes. So you have to be aware that you could get, at some point, a repository that doesn't generate events, but it has interesting data. And then there's mutable repositories, which possibly change. You don't necessarily know on what it changes, it just could change. And then those trigger events, and those events will then key you in to say, I need to go back to the repository, ask it what its new value is, and use that. So given that we have these repositories, we have potentially static or mutable repositories, what you can do is create a wrapper class around that. So if you want to create a task that's based on the contents of a repository, here's a class that you can use. I call it task repository. It's parameterized by a type R, which is the result. It extends base observable and has all these interfaces that it listens to. So repository is the main one that we're interested in. So what happens is with the task repository, you new this up and you pass it the task that you want to wrap. So it's going to hold on to that task. And what it will do is, and this is a very Agera-like thing to do, is the initial value of the repository here is going to be set to absent, which means we don't have any data yet. And it turns out absent is actually an error. So if you ask a repository what's in it, it will say it's an error. But it's a singleton error. So you can check it. You can know if there's actually nothing in here. And the reason why absent exists is that it's better than null, right? Null, what does null mean? Does it mean there's an actual value and that value is null, or does it mean the absence of data? Well, here we have a clear indicator of the absence of data, which is the singleton. So inside the task repository, there's two methods we need to implement for base observable. One is called observable activated, which means there's a listener active that's triggered from going from no updatables to at least one updatable. So when we get our first updatable, we're going to turn around and say that task that we're interested in receiving the result from, we're going to register an error and a success listener on it, and we're going to mark that we're listening. And then if the last updatable is ever removed, that will trigger observable deactivated. But there's nothing we can do. We can't remove a listener from a task. It just doesn't provide that. So we don't implement it. So there's some caveats here about that, which I will go over later. When we implement the supplier interface, we just have a get method that returns a result of type R, and we just return our result, the one that was populated from the success handler. And there's where we populate it. So you have the success listener, the failure listener, and each one of these will record the result and then turn around and dispatch that update. Dispatch update just tells Agera, let all the updatables know that we have new values here. They should be notified and they can reach back in and find it. Okay, so that's how you implement that. Now there are some caveats with this. Because repositories are far more complicated than tasks, you can never expect a task to subsume all of the things that a repository can do. So just so you know, if you do choose to use this, only the first updatable that you register on a repository or this task repository will trigger. That's the only one that's guaranteed. You could have multiple, but only the first one is ever guaranteed to trigger. And only if it stays registered when the task completes. So if you register an updatable, then take it out before the task completes, there's no guarantee that you'll ever know what happened there. And if you register a second updatable or more, those updatables will not trigger if the task already completed. So if the task completes, there's nothing listening to it. If you add a listener or add an updatable to that, it just won't trigger. I mean, that's just understood. So this repository, this task repository abstraction, only really works when you have a single value and you have one listener, one updatable, and that updatable stays registered for as long as the task takes to complete. Okay, so now you can go the other way. You can take a repository and turn that into a task. So what we do here is we use task completion source again, and we need an updatable. So remember, this updatable is the thing that you register on a repository to listen to its values. So, and I'll give the code for that in the next slide. But the scheme here is to create a task completion source, register an updatable on it, and then also call the update method on the updatable immediately. And the reason for that is if this is a static repository that doesn't generate events, we need to ask that repository if it has data and get it right away, right? Because if it never generates event, that means this task will never resolve, and you'll have listeners that stay indefinite. So we need to do two things: listen to changes and also poll to see if there's a result available right now for consumption. And then we return the task from the source. And then the update method gets a little bit hairy in here. So what happens in the update method is we have to reach back into the repository. So we say, hey, repository, we understand that you had a data change. Give me the value, check to see if it succeeded, and then resolve the task. Or if there's a failure, then resolve the task with an error. And then at the end of that, we remove the updatable from the repository so that doesn't leak. So again, pretty straightforward. But there are some caveats with this as well. You kind of have to watch out for race conditions. So if you use this in one of those circumstances I mentioned before where you have updatables coming and going out of this repository, you have a race condition where you just may never get to know the result. And that's, you have to use this repository a certain way. And it only reflects the first non-absent value. So again, repositories can change over time, but this repository, because it's backed by a task that only changes once, will only ever have absent or the result. So you have to kind of expect that. Okay, so that's all I have about tasks. Are there any questions about, yeah?
So first question. So lots of times when I'm starting a background job, I'm going to be very particular about when the callback gets called. Because, for instance, I might not want the callback to be called after on pause, say. So what's the pattern here, like, to cancel, to make sure the callback, like I know you showed the activity callback thing to make sure it doesn't get called after non-destroy, but what if I don't want it to be called back after non-pause?
So if you want your task to not trigger after a point other than on stop, you actually can't do that. And I had a conversation with the creators of the API, and I outlined examples like, maybe you want to force it away, or you're not bound to the lifecycle activity, you're bound to something else, like a service. In that case, that's actually a problem that tasks weren't built to solve. That is simply unaddressed. And I pressed the creators to say, well, why? And they said, well, it's not straightforward anymore. We've sort of violated the first condition on the first slide that the task API has to be straightforward. So when you give the ability to add and remove, you're adding a level of complexity that makes it a little less straightforward. So, yeah.
Second question is about testability. When I'm doing background jobs, espresso test, for instance, I want to be able to tell the callback, okay, run the on success with so and so result. I mean, does the task API provide patterns for our APIs to make that call that easy in tests?
Ooh, I don't know. We should talk about that afterward so I can better understand your use case. So, yeah, sorry I can't answer that right now. So I need to dig in. So, yeah, question?
So I had a question too, where you were talking about having the activity cancel the task by passing it as a parameter. What if you are doing a task in, say, a presenter or something? You don't have access to that activity. Is the typical pattern then just to create it as a local variable in the presenter and just make sure that you store it in a hash map or something like that? Or is that what we have to do?
Yeah, so the question is if you've abstracted your activity away into presenter. So the presenter is containing the presentation logic, right? You're not in an activity. Right, so in that case, yes, you would, if you want to use a task within the context of that presenter, you would have to pass along the activity instance somehow or embed it in something else. Yeah, I mean, that's unfortunate. Well, I mean, yeah, that's the only way to do it, I think. Any other questions about anything that was talked about? Not anything at all? All right, cool. Well, that's all I have. I hope you enjoy the rest of the conference. If you want to know about Firebase, we're at the table.